we have John Lynch, who is a sales engineer at AtScale. Is going to talk to us about semantic layer and what his company is all about. So, John, where is John?
I don't know.
John was here a minute ago. Where did John go?
There he is.
Hey, there he is. Okay. And so AtScale is also a Boston company, so always nice to have the locals represented. Thanks, John.
Yeah, no problem. Cool. Yeah, so the idea with AtScale is we are a semantic layer that's going to sit between your data in a data lake or data warehouse and your BI or ML tools that all need to consume that data. So we're a logical layer that's going to contain that logic and provide an interface so that all of your tools are connecting to the same logic. You're not rebuilding logic in each individual tool, which is a little time-consuming and error-prone. So currently, without a semantic layer, you're going to have all your tools connecting directly to the databases or working with extracts from the database. But with AtScale, we provide a semantic layer in between. So you model your data in the semantic layer, and then all of your tools, regardless of if it's a Jupyter notebook, in Python or Tableau, Excel, Power BI, they're going to consume the same business logic, and AtScale will actually push down and leverage the compute of the data warehouse. So instead of having to load data in RAM to do a bunch of computation, you can leverage the power of your cloud data warehouse. And that's really the advantage of moving your data into a cloud warehouse, right, is you have all of that compute available to you, and you can basically unlock that compute for all of your BI and ML tools. So what is the value of a semantic layer, right? Because we're providing that push down for those tools, you get agility to make changes to your data models without having to go and rebuild, say, physical cubes. It's all getting pushed down, so the logic changes, you make a new query, and you now have access to those changes in your BI tool. You have consistency because it's one single view that all of these tools are connected to. And you have control to make changes without having to go and figure out, where are all the places that I've defined the specific business logic. So if I'm changing the logic, I need to go and update, all of those places they're going to reference, that calculation. With a semantic layer, all you have to do is make that change once, and then all of your tools are going to pick up that change as soon as somebody, reconnects to the semantic layer. And that goes for both BI and AI workloads. So, if you make a change on the business side for your business reports, you don't have to worry about messing up the workflow of, your ML engineers who need to use those calculations in their predictive models. You update it once, and now they're pulling the exact same calculations that are driving all your BI reports. So some of the kind of inner workings of the semantic layer here is you have your semantic modeling, which is done just via a canvas, so it's drag and drop. You're setting up effectively multi-dimensional models. So you're building hierarchies, you're building your measures and your calculations in there. And what we do is take the inbound queries from whatever tool is connecting to us. So it could be something speaking DAX, MDX, SQL, and then using our multi-dimensional calculation engine, we're going to convert that into the native SQL of the data warehouse and then push it down. So we're leveraging the optimizations of the specific dialect of your data warehouse and pushing all the compute in there. So regardless of the tool and the language that it's speaking that's connecting to us, you're getting SQL out and then the compute of your data warehouse. And you get governance there because you have a single view that you can control, who sees what within your model, and you know that everybody is pulling from that single model. So the value really there is that you have this abstraction layer between the raw data and the the tools that are consuming it. So when somebody connects in with a BI tool, they're not concerned with, what columns from what tables they're interacting with. They're really just interacting with the business logic itself. So, your total sales by state, something like that. So it's much easier for people to do self-service BI because they're just dragging and dropping, in their BI tool of choice, what calculations do I want, by what dimensionality. They're not concerned with things like table joins, or any of the more complex logic like that. And again, you then have the control over the complexity of that because, you're basically deciding what you exposed to individual users. But we can also control the cost because behind the scenes, as you're interacting with your semantic model, it's learning and building aggregate tables in your data warehouse to effectively do data engineering for you. So if you have a BI report that's running slow, without a semantic layer, someone's going to have to go and build a view to speed up that query. With the semantic layer, it can learn from how everybody is interacting with your data and automatically start building aggregate tables behind the scenes and redirecting queries to those tables. The users don't need to know they exist. And so by leveraging those aggregate tables, you're going to reduce the cost of your queries because you're not going to be doing, raw table scans of your massive tables. You're going to be hitting these smaller aggregates. And then you're going to have consistency between your AI and BI tools because they're all connecting to that single place. So regardless of, where the request is made, to the semantic layer, the results are always going to be the same because the query that gets pushed down is always going to be the same. So you have that layer that's basically handling the translation from all of those different, incoming languages that BI and ML tools can speak, but making sure that you're going to have that single, dialect-specific outbound query to your data warehouse. So what does the deployment of the semantic layer look like? Basically, the idea is your data is going to get, ETL'd from your source systems into a data warehouse or a data lake, and then the semantic layer is going to sit on top of that. So basically, it understands, where those tables live, how they interact with each other, and then the logic that you've built on top of it. So your calculations, your hierarchies, and all of that. And then there's a bunch of different interfaces to actually interact with the semantic layer itself. So we can see here that Power BI is going to speak DAX to it. Excel will speak MDX. Most other tools are going to be speaking SQL, through either a JDBC or ODBC connection. And there's also a REST API that can give you access from something like a Python or just a custom application. But the idea is all of those tools are basically just writing select statements against your business logic itself. And then the complexity of, how you actually serve that request is all handled behind the scenes by the semantic layer. So that's kind of the high level run through. If you want to learn more, you can go to AtScale.com. Do you have a question there?
Are you performing transformations within the space?
Yeah, so within the actual, the modeling, you can build in, basically, there's kind of a SQL layer and an MDX layer. So our calculations themselves are written in MDX, but you can also write SQL transformations that will be applied basically before the MDX.
And are you using virtualization?
So we can handle virtualization. Generally, it's more of a case-by-case basis because, we're writing the outbound SQL, so we can connect to multiple warehouses. But we find that, especially for BI reports, it's kind of a physics problem where, you have to pay the cost of moving that data together at some point. So if, you're expecting a sub-second query in a BI tool, that's really not realistic with virtualization. But if it's something like, you have some tables in, a legacy warehouse, but most of your data is ETL'd into, say a cloud warehouse, we can handle queries that, pull from both in a single model.
Okay. Thank you.
Thank you.